Okay. We're going to work on the second derivative of the position function, right? Which is called acceleration. So when we differentiate velocity, which is the derivative of s prime t, we now get, notation-wise, what we call the second derivative. So let's double check here. This is called higher order derivatives. All right. So notice this. We do have, again, the position function. And based on a past worksheet, yes, time is greater than or equal to 0. We computed the velocity function now. So let's get the acceleration here. So your acceleration is derivative of that velocity function, which will be d dt. Velocity is 3t squared minus 8t. So, all right. That derivative will be simply 6t minus 8. So, the acceleration function here is 6t minus 8. Now remember, we're going to try to find where we have the push to the left, pull to the right, or push, pull, whatever you want to call it. Push to the left, push to the right, pull to the left, pull to the right. And when there's no push or pull, what they mean by that is simply perform sign analysis. On your acceleration function. So we start by letting that acceleration be 0. This is also, by the way, when you have velocity being a constant. But okay. Constant velocity gives acceleration is 0. So we can solve this for t now. That's what we want to do. Solve for t. If I add 8 to both sides, we get 6t is 8. Divide both sides now by 6. T is 8, 6, but what that really means is t is going to be 4/3 of your seconds. 4/3. All right. So by sign analysis again, on the acceleration function, 0 is in the middle here. 4/3 is to the right. Now this is sign analysis on the acceleration function. So really we have two regions to consider, because remember, your time again is greater than or equal to 0, which means we throw out, this portion of sign analysis. We didn't even consider it, but that's what we're going to do with this. Acceleration, we already know if we copy that, this is the acceleration function over here. All right, we need some time values. 4/3 is bigger than 1. So 1's available, and 4/3 is smaller than 2. So we're going to use those two test point values. Okay. We're going to test the region, test the signs. So when t is 1 now, you get 6 times 1 minus 8, which is 6 minus 8. That is -2. So in region 1 there, acceleration is actually negative. So the particle is being pulled to the left for those values there between 0 and 4/3. Okay, let's test the value of 2 in sign analysis. So here again, here's where 2 is. 2, you get what? 6 times 2 minus 8, which is 12 minus 8. The answer is 4 now. So, ladies and gentlemen, that's a positive 4. So, let's keep with our convention. I think going to the right was green, and going to the left was orange. But this is not velocity sign analysis, it's acceleration. We're talking push or pull now. So the first thing we want to know is where there's no pull, no push or pull. That happens when your acceleration is 0. That's also when you have, by the way, constant velocity. You'll have no push or pull because that means acceleration will be 0. That happens when t here is 4/3 seconds. Because we already found where acceleration, this is acceleration function, is 0 at 4/3 seconds. Now, you're going to have, we'll call this we'll say pull to the right, okay? Where your acceleration is strictly positive. That means it's for values of t on our sign analysis that are bigger than 4/3. So t has to be greater than 4/3 here. Greater than 4/3 seconds. As interval notation, that's 4/3 up to infinity. Okay. Pulled to the left now, negative acceleration. Now, we include 0 here. Okay, and that's open parentheses because at 4/3, acceleration equals 0. It's not negative. 0 is not negative. It's not positive. 0 is neutral. So we'll say now here for the pull to the left now, our left pull, your acceleration has to be negative. And then that happens again for t being between 0 and 4/3, but we include the 0. This is a square bracket here. And you say, why? Well, you don't have a 0 above 0. It's only above 4/3, so that means it's negative. Okay. In terms of interval notation, you have a closed bracket around 0 and an open bracket around 4/3. And, let's just color coordinate everything. There's no pull for this time. You got a right pull for this time. And then you got a left pull for this time. So, ladies and gentlemen, there you guys go. This is how this works here. It's your sign analysis. All right, let's try this out again for question number 5. Question 5, we had the position function for time values being greater than or equal to 0. Then we computed the velocity function. This is about acceleration now. So acceleration is the derivative of velocity. Give you every detail. Velocity is 15t squared minus 8t. When I differentiate, we get 30t minus 8. Here's our acceleration function. This is what we have to form sign analysis on. So you got sign analysis on the acceleration function. All right, start by setting the acceleration function equal to 0 and solve for t, because this is the process of sign analysis. Solve for t now. So 30t is 8. Divide both sides by 30. T is going to be 8 over 30. That reduces to 4 over 15, and this is seconds. Okay, this is how we go about this again. So we only have one value. I'll label 0. 4 over 15, this is the acceleration function. This is where acceleration is 0. It's not 0, ladies and gentlemen, when t is 0. And just remember, we have to throw out the time values that are negative because we're dealing strictly with t being greater than or equal to 0. So that portion is gone. We have region 1, region 2, if you want to call it that. Let's look at it this way, maybe. Right? Don't forget to bring down your acceleration function. And, I might just keep it blue. That looks a little better. Let's copy that. All right. We need test points now. So let's be careful. In region 1, we got 4/15. I'm going to use like 1/15. Then we use the number 1. These are going to be my 2 test points. I'm picking a number in region 1 I could test the sign with. So 1/15, we get 30 times 1/15 minus 8. That'll be 2 minus 8, which is -6. So double check. I know that 15 is doing something weird. 30 times 1/15 is 2. So region number 1 is negative. The particle's being pulled to the left in region 1. Okay. We're going to do the test point now of 1 and see the sign of region 2. So this gives me 30 times 1 minus 8. And again, I don't like that. I don't know why it does that. 30 times 1 minus 8 gives you 30 minus 8. And that's going to be a positive 22. Region 2 is positive for acceleration. So we're being pulled to the right in region 2, and we're being pulled to the left in region 1. There is no pull when t is 4/15. So ladies and gentlemen, we're ready to formally answer our push and pull, really acceleration questions. All right, let's see what that means here. So your particle is really no push or pull. You have we'll say no pull when acceleration is 0, and then that happens when t is 4/15 seconds. We already answered that. That's what they're talking about right here. Particle will be pulled to the right when your acceleration is strictly positive. Well, the acceleration again is strictly positive over in region number 2. So we're going to use that open parentheses. What that's a picture of is saying all the time values are bigger than 4/15 of a second. That's when you're going to have what we call a right pull. You want a left pull. I guess, I don't know, how are we saying that? Left pull, pull to the right, which one? pull to the left. Okay. Guess we want the word pull first, but it doesn't matter. Particles being pulled to the left when your acceleration is negative. Acceleration is negative, ladies and gentlemen, right in this interval here between 0 and 4/15. That's because of our sign analysis. So what does that mean? And let me be careful again, because at 0, we don't have a 0 up above it. So at 0, it's a square bracket. We include 0. 0 to 4/15. So we're going to say 0 less than or equal to t less than the 4/15 of a second here. And then that's where you have the left pull. So there's your information on acceleration. No pull, pull to the right, pull to the left. Sign analysis on the second derivative of the position function, which means it's acceleration. And then that's question 5, and that means we're done. So I'll send this to you guys as well, and I hope you enjoyed the demonstration.